vectors in 3D space. So most of high school math is done with two-dimensional space, but in real life, it's 3D. So here's like a little snippet of 3D math, basically, with vectors. It's not too bad, I promise. It's just basically like taking what we did with 2D and now putting it in 3D. So if you read through here, it says like in a Cartesian coordinate system, a plane is divided into 4 quadrants, the x and y axis. Okay, but to represent 3D space, you need 3 dimensions, so that's where z comes into play. So this is the x and y, what we're used to, but the z is what's new. So then it technically divides it in 8 regions. So you have like, if you think of this as the top, that would be the bottom down here. 1, 2, 3, 4, and then you'd have the bottom, so then 8. So, and it's written as, I don't know why I put organized. It should say coordinate triple, but it's okay. So coordinate point is 2-dimension, but coordinate triple, or a triple ordered triple, yeah, coordinate triple or ordered triple, either way, is the same concept. Why is that going away? Okay, so we've done the distance formula forever with 2-dimension, but the question is how do you do it with 3 dimensions? So if you're trying to go from point A to B and you want to find that distance, I'm just going to write it so you know what you're finding. Instead of doing like the difference between the x's and the y's and that's it, and you add it together squared, you have to do the difference between the x's squared, the difference between the y squared, and the difference between the z's squared. So it looks something like this. So it's really not that much, but writing it out is a lot. So, and of course under the square root. So the midpoint formula is kind of the same situation. I'm just going to put m for midpoint. Now it's midpoint formula. It was always an ordered pair. So this is an ordered triple. It's actually a location. So you need like a location with an ordered triple. So when you find the midpoint formula, it's just basically finding averages. So you add the x values together and divide by 2, and then the y's divide by 2 because there's 2 of them, and then the z's. And it doesn't matter what order because order of addition does not matter. So if we wanted to find the length of this point, you have to find basically the magnitude. So you would do this, and I'm going to write RS equals, and you're going to take 4 minus negative 1, I'm not writing this out, and 4 minus negative 1 is 5, so we have 5 squared plus, and then it's 0 minus 2, which is negative 2 squared, and then 9 minus negative 5, which is 14 squared. Okay. If you put that all together, you get 225, and that is 15, and I'm going to put units. Okay. If we wanted to find the midpoint, remember you add the points. So 4 plus negative 1 is 3, and we divide it by 2. You would have 0 plus 2, or 2 plus 0, which is 2 divided by 2, and 9 plus negative 5, which is 4 divided by 2. So you end up having 3 halves, 1, and 2. So it's really not that difficult. Okay. Now if you put it with a little bit of content, which they do actually do vectors with air traffic controllers. My brother told me they do. A little different with helicopters. That's a different type of air traffic controllers. But these would be like the coordinates, okay? You can find the distance between those helicopters by doing this distance formula. So you would do, and again, I'm not going to show all my work and I'm using a calculator. So you would do 150 minus 400, and I want to make sure I do this right. So that's negative 250 squared, and then you would do negative 300 minus 200, which is negative 500 squared, and 5,500, or 5,500 minus 3,000, which is a big number, 2,500 squared. Okay. If you put that all in your calculator, you get this number. And I don't want that as an answer with it being a real life situation. I want a decimal answer, or an actual answer, as you would say. And I'm just going to go to 2 decimal places and It doesn't say units or miles or anything, so we're just going to put, it doesn't say the unit, we're not going to assume miles, so I want to put units, okay? All right. That is the end of the first video, and we're going to move on to the next page in the next video.